So for problems like these, here we have a higher root and we have all kinds of crazy business going on inside. You have coefficients and then you have variables to a power. And you do have to kind of treat everything separately. So I'm going to treat the 64 differently from the x to the 7th, differently from the w to the 10th. But it really is all the same rules. For the coefficient, the first step is to take that 64 and go back to that whatever math this was and break it down into its prime factorization. There's a lot of ways to break it down, but no matter what you do, if all your math is correct, you're going to end up with 2 to the 6th power. And so let's just kind of look at this like this. The fourth root of 2 to the 6th, x to the 7th, w to the 10th. I'm going to try to explain this slightly differently from the previous example. And here's how I'm going to do this. I'm going to play a quick little game called It Would Be Awesome If. And here's what would be awesome. It would be awesome if each of these powers was a multiple of 4. So I'm going to make up a totally different example where that's actually what happens, and I'll tell you why that would be awesome. If this was, say, the fourth root of, let's go with like 2 to the 12th, x to the 8th, w to the 20th, that would be awesome. Here's why. Because we know that when we're looking for a fourth root of something, we're looking for something that multiplies by itself 4 times to give you what's inside of here. And so, for example, if I wanted the fourth root of 2 to the 12th, I'd be thinking to myself, what can I raise to the 4th power to get 2 to the 12th? And it would have to be 2. And I hope we can all see that would be like to the 3rd power then, because we know that if we have a power to a power, we multiply the powers together. So going backwards, I could simply take this 12 and divide it by the 4 and know that the 4th root of 2 to the 12th would equal 2 to the 3rd. That's a little bit hard to see. People see it easier with the letters, so let me try that instead. If I was trying to find the 4th root of x to the 8th, we know we're looking for something that I can raise to the 4th power and have it land on x to the 8th. So what can I raise to the 4th power to get x to the 8th? And hopefully you can see it's x squared, because you know that if you take a power to a power, you multiply the power. So again, if I had the 4th root of x to the 8th, I could simply take this power and divide it by that power and know that the answer would be x squared. Think about that for a second and try to do the w before I do it. If I were dealing with the 4th root of w to the 20th, I'm looking for something that multiplies by itself 4 times to give me w to the 20th. So in my brain I'm thinking, what to the 4th power equals w to the 20th? And I think same power, right? Same principle. If I raise a power to a power, I'm going to multiply the powers together. So I know it's going to be w to the 5th. I know this would be w to the 20th. I can get that same answer by taking this power and dividing it by that power. That would be w to the 5th. So it would be really awesome if these were all multiples of 4, because then I could simply divide, divide, and divide. The problem is they're not. So what we're going to have to do is break these up using a different property so that we have things in here that are multiples of 4. And here's how that's going to look. So what I'm going to do is take this 2 to the 6th, and I'm going to think about the lowest multiple, the biggest multiple of 4 that's lower than 6. So what's the biggest thing 4 goes into that's lower than 6? That, of course, is 2 to the 4th. And what's the remainder? How many are left? I'd have 2 squared left. Before you say this makes no sense, think about this. If I gave you these two things to multiply together, and I know it's strange when the bases are actual numbers, but if the bases are the same, we add those exponents together. So 2 to the 4th times 2 squared is the same thing as 2 to the 6th. But this is a multiple of 4. Same question for this. I need to find a multiple of 4 that's less than 7. So that would be, again, that'll be x to the 4th. And if I were to take 4 of these x's, there'd still be 3 of them that were left. So I'd have an x cubed. And just to kind of reinforce old concepts, if you had to multiply these together, you would add the exponents. So this does together make x to the 7th. And then finally, that w to the 10th, we need a multiple of 4 that's less than 10. So that would be 8. Leave me with 2 left. And now what's going to happen is all these guys that are multiples of 4, these we can deal with. So I'm going to just take this power, divide it by that power. That'll just be plain old 2. What to the 4th gives me x to the 4th? What to the 4th gives me x to the 4th? Just plain old x. What to the 4th gives me w to the 8th? what multiplies by itself? Well, yeah, what to the fourth gives me w to the eighth, and I hope you can see w squared. Because if I were to take w squared to the fourth, that would be w to the eighth. And then all these things that are left, they're left behind. They're left behind. So what's the fourth root then of 2 squared makes 4. X to the third is just x to the third. And then w squared is w squared. There's another way to look at this, so I'm going to explain it in a slightly different way. So if this did not make a ton of sense, you might check out alternative solution number 2.